This is a topic on permutations and combinations, and we start off with permutations. Permutations are the number of ways in which things can be arranged. Remember, when you look at permutations, the order does matter. You having something first and second does matter. Okay? The main counting principle that we're using here is that if there are m ways to do one thing and n ways to do the other thing, then in order to do both, which is the intersection, will be m times n. For example, a restaurant offers a choice of 3 starters and 6 mains. So 3 ways of getting starters and 3 ways of getting mains. How many different combinations can be chosen? Again, quite simply using the fundamental counting principle, 3 times 6, which will give you 18. So there are 18 possible combinations of you choosing a starter and a main. Next up, we look at the factorial function and what exactly that is. So factorial function from your calculator is the thing with an exclamation mark, where you press shift and this button right here, which will give you this thing here. And what it does is, for example, if you write 4 factorial, what that does is it takes 4 and multiplies by each number below it until you reach 1. That's what that does. Just keep that in mind because we use that a lot in this topic. When you're looking at permutations, when you have n distinct objects, meaning you have a number of distinct, that means they can be differentiated. For example, if you have A, B, and C, these are 3 letters that are distinct that can be differentiated. A is different from B, which is different from C. There, when you want to arrange them, what you do is you have 3 spots available, because remember you have 3 letters. And initially for the first spot, you have 3 options. 3 options being A, B, and C. Then remember, that option that you put in the first seat is now gone. So for a second seat, you have 2 possible options. And again, your second option is gone again. Therefore, in the last seat, you just have 1 option. Now remember what we said. There are 3 ways of choosing the first seat, 2 ways of choosing the second seat, and 1 way of choosing the first seat. And so if you want all seats together, what you're going to do is multiply them to each other. Therefore, how many ways can the letters A, B, C be arranged? That's going to be 3 times 2 times 1, which is going to be 6. And remember what this is? We just learned in the previous slide. It is 3 factorial. Same thing here. How many ways can the letters A, B, C, D be arranged? Again, there are 4 distinct objects, distinct letters. And so there are 4 different ways of choosing the first one. Then that choice will go away. And there'll be 3 ways of choosing the second one. Then those 2 choices will go away. Then there are 2 choices of picking the third one. Then those 3 will go away. And finally, we are left with 1 alone. And if we want all of these to happen, we will just be multiplying them to then give us 24 as our answer. So there are 24 ways that the letters A, B, C, D can be arranged, which again is the same as 4 factorial. That's what this is right here. Same thing for this, 5 letters. You get the gist, it's going to be 5 factorial because there are 5 options. Then they go down to 4 options, then 3, then 2, then 1. Then what if you have n objects, but not all of them are distinct, meaning there are some repetitions? Then obviously things would change. For example, how many arrangements can be made with the letters A, L, and L? I'm going to show you all the possibilities that are there for this arrangement. But I'm going to make these L's distinct. Yeah. So A, L1, L2, A, L2, L1, L1, A, L2, L2, A, L1, L1, L2, A, and L2, L1, A. So there are 6 possibilities if those L's were distinct. But remember, these 2 are the same. These 2 are the same, and these 2 are the same. Why are they the same? Because the L's have no difference between them. So whether we have LAL or LAL, these are the exact same things because they are repeated letters. And so what happens here, from the original 3 times 2 times 1, because there are 3 letters, which gives you 6 possibilities, which are all these 6 that are there. What happens is you remove half of them. Why? Because there are 2 repeating letters, and so what you will do is divide by 2 factorial, which is just 2 times 1. What this does is cancels this out, which leaves you remaining with 3 as your answer. So when there are repetitions, you have all the letters that are there. So 3 factorial. We would leave this as this if all the letters were distinct. But because there are repetitions, we will divide it by how many times that letter is being repeated. So L is being repeated twice, so it will be divided by 2 factorial, which gives us our answer of 3. Next, what about monopoly? Usually what we would do is, if all of them are distinct, count the letters 1, 2, 3, 4, 5, 6, 7, 8, and we would just do 8 factorial. But we have repeating letters. What are the repeating letters? We have O 3 times, and that's it. And so what we would do to this is we would divide it by 3 factorial because O was repeated 3 times. Okay, what this does is from 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, we will divide it by 3 times 2 times 1, and these stuff will cancel out. Therefore, we're just left with this. And that will give you 6,720. So there are these many ways that the letters monopoly can be arranged. Finally, what about parallel? If we see parallel and we write this according to repeating, this is how I like to do it. P, A, R, A, L, L, E, L. I wrote parallel where I have clearly indicated how many times each thing has been repeated. Now, how many letters are there in total? 1, 2, 3, 4, 5, 6, 7, 8. Again, if they were all distinct, we would just do 8 factorial. But because they have repeating letters, this time there are 2 sets of repeating letters. Remember, if we have a specific letter repeating 3 times, as we had above with O, we would just divide by 3 factorial. But now this happens twice. So what we would do is take that whole thing now, because now we have already accounted for the 3 L's. We still have the 2 A's that we have to account for. So again, we will divide that by 2 factorial. What this does is gives you this thing right here. So 8 factorial divided by 3 factorial times 2 factorial. So on your denominator, what you will be dividing is the factorial of all the letters that are being repeated. Obviously, the number of times those letters are being repeated, which will then give you the answer for that question, which will be 3,360 in this question here.